Okay, hi, good evening, everyone. So today I'm going to take some of the back questions from book Essentials of Econometrics by Gujarati, right? And this is going to be chapter number 8, which is multicollinearity. Okay. All right, beta. Let's go ahead and let's look into the question. So you are given this regression function, and the question is asking, so you're given that y refers to the output and x refers to the input. But x is your input and y is the output. This is a back question of Gujarati. It says, is there perfect multicollinearity? Do you agree? Why not? Very good question. So try to see this thing. देखो, हमेशा से हमने मल्टीकोलिनियरिटी में ये पढ़ा है that in multicollinearity, the relationship between the variables, the independent variables, it should be basically your linear relationship. It should not be non-linear relationship. It should be a linear relationship. So for example, we have studied that something like this. Sometimes we have studied that, if xi, x3i, it is equal to 2 times x2i, then it refers to perfect multicollinearity. Or when x4i is equal to 2x2i plus 5, it refers to perfect multicollinearity. So in multicollinearity, whenever we have talked about the relation between the independent variables, जब हमने एक्सेस के बीच के relation की बात की है, we have always talked about the linear relationship. We have always talked about the linear relationship. But here the relationship is not linear. Rather, the relationship is non-linear. As you can see that this is simply square of this. This is simply cube of this. So this is not a problem of perfect multicollinearity. Rather, this regression function that we have, this is actually an example of polynomial regression function. Right? This is an example of polynomial regression function. This is not an example of your perfect multicollinearity, because the relationship is non-linear and multicollinearity only deals with linear relationships. So we can go ahead and say, it says, is there perfect multicollinearity? No, there is not perfect multicollinearity. Do you agree? Why not? So I have written no multicollinearity refers to linear association among the variables. Here the association is non-linear. Am I clear with it, beta? Okay, beta. Come to the next question. So these are the statements given under true and false. Let's look into the first statement, beta. What it says? It says, despite perfect multicollinearity, OLS estimators are blue. Now it is talking about perfect multicollinearity. So let us take a model beta. So suppose I tell you that y is equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui. Suppose I give you this model. Then what you can go ahead and you can see, you can notice, suppose I give you a relationship and I tell you x3i is equal to 2 times x2i. Right? This is a perfect multicollinearity. This is what it is saying. Despite perfect multicollinearity. So I have taken one perfect multicollinearity relation. मैंने एक random assumption पे एक perfect multicollinearity relationship बनाया है. Suppose I am assuming that x3i is 2 times x2i. So what will happen in this case, beta? I will get y is equal to beta 1 plus beta 2 x2i plus beta 3 2x2i plus ui. So when I will solve this, I will get beta 1 plus beta 2 plus 2 beta 3, I will take common, x2i plus ui. And this will give me beta 1 plus a2 x2i plus ui. So actually I will not be able to get back the original betas. In betas को तो मैं estimate ही नहीं कर पाऊंगी. The maximum I will be able to estimate will be beta 1 and a2. This 3-variable regression model will actually be converted into a 2-variable regression model. So when you cannot estimate the parameters itself, how will we talk about their properties? हम इनकी properties की कैसे बात कर सकते हैं जब हम इनको estimate ही नहीं कर सकते हैं? So this is what I have written here, that this statement is false, right? This statement is false. If exact linear relationship exists, we cannot even estimate the parameter. अगर हम इन coefficients को estimate नहीं कर सकते, then we cannot talk about their properties. So we can say that, we can just write here additional line, that since the estimators cannot be estimated, we cannot comment on their properties. Right, beta? So this is a false statement. Okay, come to the next question. Again, beta, you have to tell whether the statement is true or false. It says, in case of high multicollinearity, it is not possible to assess the individual significance of one or more partial coefficients. This is again false, right? It is saying high multicollinearity. It is not saying perfect multicollinearity. So suppose I tell you, for example, I give you a model yi is equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui. And I am telling you that there is high correlation between x2 and x3, but not perfect. Highly correlated तो है, पर perfect correlation नहीं है, right? So when there is no perfect correlation, तो बेटा I will be able to tell about the t values ना. तो जैसे if I give you a model yi is equal to 108.2 plus 0.95 x2y plus 0.87 x3i plus ui. And suppose I give you their standard errors also. मैंने यहाँ पे standard error लिख दिए कुछ. ठीक है? You will be able to tell me the t value. आप t value estimate कर पाओगे. T value will be nothing but b2 upon standard error of b2, b3 upon standard error of b3. तो ये वाला t values तो आप निकाल पाओगे ना? You will be able to find the t value. And then you will be able to also compare that if t calculated is more than t tabular, then you will be rejecting null in favor of alternative, isn't it? So you will be able to go ahead and you will be able to tell about individual significance. You will be able to assess, to mention about individual significance. उसके बारे में आप बात कर पाओगे. So therefore, we can say that this statement is false because this statement is saying that it is not possible to assess individual significance. But we will be able to assess individual significance. हम individual significance की बात कर पा रहे हैं. We are able to talk about that. Am I clear with it? Okay, beta, come to point number 3. Read it out. If an auxiliary regression shows high R square, then it is an evidence of high multicollinearity. Beta, we have talked about something which is called as the variance of betas. Right? When we estimate the variance of betas, जब हम beta hats actually, तो वो वेरियंसेस क्या हो जाते हैं? सिग्मा स्क्वायर अपॉन समेशन एक्स जे स्क्वायर 1/1 माइनस आर स्क्वायर या सिग्मा स्क्वायर अपॉन समेशन एक्स जे स्क्वायर इनटू VIF. ऐसा करके हमने वेरियंसेस लिखे थे. So you need to understand that when we were finding these variances of B's, तो उस केस में यहाँ पर ये R square आ रहा था. This R square was coming here, है ना? And we had found out कि suppose, just try to understand this thing, that if this R square is high, right? So 1 minus R square will be low. If 1 minus R square will be low, so variance of B2 will become high. If variance of B2 will become high, so individually they will become insignificant. Individual significance will be low. Betas individually significant नहीं होंगे. क्यों? क्योंकि when we found out the t value was B2 by standard error of B2. और ये कुछ नहीं है, बट ये तो रूट अंडर रूट ऑफ वेरिएंस ही है. तो अगर वेरिएंस हाई होगा तो स्टैंडर्ड एरर भी हाई होगा. अगर स्टैंडर्ड एरर हाई होगा, इफ स्टैंडर्ड एरर विल बी हाई, तो टी वैल्यू विल बी लो. अगर टी वैल्यू लो होगी तो टी कैलकुलेटेड विल बी लेस देन टी टैब्यूलर. If t calculated will be less than t tabular, so you will find them individually insignificant. Individually insignificant. Are you able to understand the entire thing? It will be individually insignificant. Multicollinearity exists when they are individually insignificant but jointly significant. This is a symptom of multicollinearity. This is a symptom of multicollinearity. Clear? Okay. Now, at the same time, suppose when R square is high, right? Suppose sigma square is low. So when sigma square will be low, it will reduce the variance. When variance will lower, so standard error will lower, so t value will increase, t calculated will increase, it will become significant. So I will not be having the problems associated with multicollinearity. Interpret करना पड़ेगा. It will take time. समझ रहे हो बात को? तो therefore, re-listen to me what I have said. दोबारा back करो, दोबारा सुनो. Try to keep listening this again and again and again. So what I am saying is that R square is not a very reliable indicator of multicollinearity. R square अगर high है, पर sigma square साथ में low है, तो variance low ही रहेगा. Variance low रहेगा, तो standard error low रहेगा. स्टैंडर्ड एरर लो रहेगा तो टी वैल्यू हाई रहेगा. टी वैल्यू हाई रहेगा तो टी कैलकुलेटेड हाई रहेगा. टी कैलकुलेटेड हाई होगा तो इंडिविजुअली सिग्निफिकेंट हो जाएगा. इट विल बी इंडिविजुअली सिग्निफिकेंट, राइट? So saying that R square can be a good indicator of multicollinearity is not enough, right? High R square is only a surface indicator of multicollinearity. मतलब complete indicator नहीं है. एक basic ऊपर surface means एक ऊपरी तौर पे बताता है that multicollinearity can exist. But it may not always end up inflating the variance. हमेशा R square बढ़ने से variance नहीं बढ़ेगा. Because it can be counterbalanced by low sigma square or high समेशन xi स्क्वायर. अगर ये भी बढ़ जाता है तो ये गिर जाएगा, अगर ये गिर जाता है तो ये गिर जाएगा. And when this will fall, the standard error will automatically fall. Am I clear? Very, very difficult concept to understand, but important. Another way in which it can be asked in exam. So suppose in exam they ask you that true or false statement, that high R square implies high variance of slope coefficients. High R square implies high variance of slope coefficient. हाँ बेटा, तो फिर से same चीज है बच्चे, that variance of B2 can be written as sigma square upon summation xj square into 1 upon 1 minus R square. Right? So when R square will increase, so 1 minus R square will decrease, denominator will decrease, so this can increase. But if at the same time, अगर उसी time पे the sigma square is low और this is high, तो जब denominator ये वाला increase होगा तो ये वाला decrease हो जाएगा. जब sigma square will decrease तो ये increase हो जाएगा. I mean ये decrease हो जाएगा. So if it is counterbalanced by the movement of sigma square or summation xi square, then the variance will not be high, even with high r square, right? So the statement becomes false. Okay, beta, come to the next statement. It says, high pair-wise correlation do not necessarily suggest there is high multicollinearity. High pair-wise correlation does not suggest high multicollinearity. This is an uncertain statement. It depends on whether you have just two regressor or more than two regressor. Okay. If you have only two regressors and one regressant, मतलब अगर मेरा मॉडल ये है y is equal to beta 1 hat plus beta 2 hat x2y plus beta 3 hat x3i plus ui, and I have high multicollinearity x2i x3i के बीच में high multicollinearity है, माने इनका पेयर वाइज कोरिलेशन हाई है, तो डेफिनेटली हाई मल्टीकोलिनियरिटी होगी. But if my model is this, y is equal to beta 1 hat plus beta 2 hat x2i plus beta 3 hat x3i plus beta 4 hat x4i plus beta 5 hat x5i plus ui. If this is my model, अगर मेरे मॉडल में दो एक्सेस से ज्यादा एक्सेस है, if I have more than two एक्सेस, तो बेटा सिर्फ इन दोनों के हाई पेयर वाइज कोरिलेशन से कुछ इंफॉर्मेशन नहीं मिलती है कि वेदर इस पूरे रिग्रेशन का जो मल्टीकोलिनियरिटी है वो हाई है या लो है. इट गिव्स मी no extra information. It does not go ahead and suggest anything about multicollinearity within the model in this case, right? So high pairwise correlation in this case does not imply that I will have high multicollinearity. But if there are only two of these x's and the pairwise correlation is high, then it definitely implies that I will have high multicollinearity. Am I clear with this? Okay, beta. Come to the next statement. What is the statement saying? Multicollinearity is harmless if the objective of the analysis is prediction only. This is actually a statement given in Gujarati itself. ये Gujarati का ही अपना statement है, which goes ahead and it says that, you know, there are two things that I am using regression for. The first thing is I want to estimate betas well. मेरे को एक अच्छा regression बनाना है और मुझे ये beta hats को अच्छे से estimate करना है. The second thing is that I just want to go ahead and I want to use this equation to predict the future. कि you give me a relation that the equation is y is equal to 108 plus 0.87 x2i plus 0.82 x3i plus ui. And then I will give you some values from the future. कि in 2030 x2i x3i इतना होगा, and you give me y. So Gujarati says that if your aim is just prediction, then multicollinearity will be less harm. But if your aim is to get better estimates, then definitely multicollinearity is harmful. And here also, it may happen that the correlation will change. जैसे आज शायद ऐसा हो कि x2i और x3i का जो correlation है, that is 0.87. But what if their correlation changes with time? तो आपका prediction will also be not good enough because the relation between these two have changed and they are related to each other. So this model itself will not be a good model to use. So multicollinearity is harmless if objective is prediction, partially true, not completely true, because in the future this relationship between the regressors might change. ये relationship भी change हो सकता है, right? So please read this out. I have written the answer to this. Uncertain. This statement is uncertain, neither completely true nor false. If the goal of the study is to use model to predict or forecast the future, अगर काम सिर्फ prediction है, then collinearity is not that bad. तो collinearity बहुत ज्यादा बुरी बात नहीं है, provided that the relation remains the same over time. सिर्फ तब वो बुरी बात नहीं है अगर relation same ही रहेगा time के साथ. However, if the objective of study is not only the prediction but reliable estimation, बट अगर मेरा ऑब्जेक्टिव ये है कि इन बीटास को मुझे अच्छे से एस्टिमेट करना है, आई वांट टू एस्टिमेट द राइट वैल्यू ऑफ द बीटा, आई वांट दैट दे शुड बी द बेस्ट लीनियर अनबायस्ड एस्टिमेट्स, देन डेफिनेटली मल्टीकोलिनियरिटी इज बैड. उस केस में मल्टीकोलिनियरिटी बहुत ज्यादा खराब है एंड इट मस्ट बी टैकल्ड, राइट बेटा? So these are some of the questions I wanted to discuss in this lecture. These are the back questions of Gujarati, and you can go ahead and use this lecture to see the solutions. Okay, beta, thank you.